Today we're going to look at SUVAT equations. There are 4 equations of motions and we call them the SUVAT equations. First one is V is equal to U plus AT. Second one is V squared is equal to U squared plus 2AS. Third one is S is equal to U plus V all over 2 times T. And finally, S is equal to U T plus half AT squared. Let's start with an example. A car accelerates from 10 meters per second to the minus 1 to 30 meters per second to the minus 1 in 5 seconds. What is its acceleration? With these SUVAT equations, you should start by writing SUVAT on the side of your page. If you're uncertain what these symbols represent, I'll go through them. So S is equal to displacement or distance, and that is measured in meters. U is the initial or beginning velocity, and that is measured in meters per second to the minus 1. V is the final velocity, and that is also measured in meters per second to the minus 1. A is acceleration, which is equal to meters per second to the minus 2, and T is time, which is measured in seconds. So we identified the 4 formulas that we have, and this key skill for this is trying to identify what you have from the question and what you're trying to calculate and which formula to use. So we write out our SUVAT and we identify what we have. So we know that 10 meters per second is the initial velocity. The car accelerated 30 meters per second to the minus 1, so that is the final velocity. And then that took 5 seconds. You're trying to calculate the acceleration, but you're not given anything about displacement. So if we look at the 4 formulas, any ones with S in it, we cannot use because we're not given any information about them. So the only formula that doesn't have S in it is the first one, and that is V is equal to U plus AT. So next step you have to do is rearrange your formula. To do this, V is equal to U plus AT. You bring first of all your U over, so it becomes a minus U. So V minus U is equal to A times T. Then you divide both sides by T because that AT is being multiplied by each other. So the only way to get rid of the T is to divide it out. So V minus U all over T is equal to A. So this is the formula we will use. Now we submit in our values. So A is equal to 30 minus 10 divided by 5. And once we calculate that out, we find that the acceleration is 4 meters per second to the minus 2. Key skills when doing this: identify what you have, what you don't have, rearrange the formula, submit in your values, and then don't forget your unit. Next one we'll have a little look at. An aircraft was travelling at a speed of 60 meters per second to the minus 1 when it landed on a runway. It took 2 minutes to stop, calculate the acceleration of the aircraft while coming to a stop. So this one, again, identify what you have and what you don't have. So U this time is 60 meters to the minus 1. V is the final velocity, which is 0 meters to the minus 1. Here we're given time as 2 minutes. Now remember our SI units. Minutes is not an SI unit, so we need to convert it to seconds, which is 120 seconds. And again, we're told nothing about displacement, so we can use the same formula. For this, we just submit in our values again. So A is equal to 0 minus 60 all over 120. And that will give you minus a half, or A is equal to minus 0.5 meters per second to the minus 2. The minus sign represents deceleration. So if you see a negative sign in front of your answer, it doesn't mean that it's incorrect. It just can mean that the vehicle, or for this example, the aircraft, is decelerating. Finally, we'll have a look at this question. A motor car travelling in the Formula 1 race travels at 40 meters per second to the minus 1. It brakes suddenly and comes to a halt in a distance of 860 meters. Firstly, calculate the braking time, and then secondly, the deceleration of the car. So we'll start with calculating the braking time. Reminder of the 4 formulas. And we write out our SUVAT. So this time we are told that the initial velocity was 40 meters per second to the minus 1. The final velocity was 0 meters per second to the minus 1. And that we're given distance this time, which was 860 meters. We're trying to calculate time. We are not given any information on acceleration. So we look at our 4 formulas. Anything with A in it we cannot use. So the only formula that doesn't have A in it is the third one. So we want to use this formula to calculate time. But we have to rearrange the formula that T equals everything else. So S is equal to U plus V all over 2 times T. So 2S is equal to 2 times U over V times 2 times T. If you're wondering where we're getting the 2 is, U over V divided by 2 is the same as half U plus V. So you're multiplying by 2 to get rid of that division of 2. So what you have here is 2S is equal to U plus V times T. Now, we still have U and V multiplied by T, so we need to get rid of the U and the V. So the best way to do that is, again, divide it out. And what you get is 2S is all over U plus V is equal to T. This is the formula that we will use. So we just submit in our values. 2 times 860 all over 0 plus 40. And that is equal to 43 seconds. Okay, so we've calculated the time as 43 seconds. Now we want to calculate the deceleration of the car. Or for this, if you see deceleration, you can assume the acceleration formula. So again, we write out what we have this time. So now we have pretty much everything apart from acceleration. We calculated time last time. We look at our 4 formulas. Now, out of the formulas, you can see that there's a lot with acceleration in it. So we're going to just pick the easiest one to work with, which is the first one. Okay. So V is equal to U plus AT. So we rearrange our formula again, submit in our values, and the acceleration calculates as minus 0.93 meters per second to the minus 2. So again, this vehicle is decelerating.